Hello, welcome to Chapter 8, questions 92 through 97. Question 92, Quality Control Part 2. Lots Odo, a wealthy customer, would like to order a variety of parabolas. However, he is feeling pressed for time and said that he will pay you lots of extra money if you complete his order for him. Of course you agreed. He sent you sketches of each parabola that he would like to receive. Determine a possible equation for each parabola so that you can pass this information on to the manufacturing department. All right, so let's take a look at Part A here. What information do we know? We know that the x-intercept, one of them is at -4, so x equals -4, and x is equal to 2. So we're going to work backwards. We'll add 4 to both sides. Set that equal to 0. Subtract 2 to both sides. And that gives us our factors, and then we can take these factors and work backwards to set them up as our zero product property, where usually we split them apart. Now we can multiply them together, get x squared plus 2x minus 8 is equal to 0, but we want to write it as an equation, so we want to say y equals x squared plus 2x minus 8. So that would be the parabola, at least one possible parabola for Part A. Part B, so this one we only have one x-intercept, and since the y-intercept's not labeled, we don't have that either. But what we found out is when a parabola touches the x-axis instead of actually crossing through it, it still gives us 2 of the same factors. So x equals 3 happens twice. And so when you subtract 3, you get x minus 3 equals 0. And once again, you get it twice though. So x minus 3 times x minus 3 is equal to 0. This would represent one of your perfect square trinomials. So this would be x squared minus 6x plus 9. And we want to write it as an equation, so we have y equals x squared minus 6x plus 9. All right, and now on to Part C. C, we have 2 values again. We have x equals 0, it crosses at the origin, and we also have x equals 7. So we'll work this one the same way we did on Part A. Now, there's nothing to do with the x equals 0. That's just your factor x. This one we can subtract 7 to both sides. So our 2 factors are x and x minus 7. And then when you multiply those together, you get y equals x squared minus 7x. And so there's that equation. And then the last one on D. We have 2 here. We have a -5, so x is equal to -5, and we also have x is equal to 1. But notice that our parabola is opening down, so we got to keep that. We got to remember that. So when we go to write the equation, we need to have a negative in the front, so it opens down. So let's see what we got here. We add 5. X plus 5 equals 0. Subtract 1. And so those are our 2 factors, x plus 5 and x minus 1. And we'll multiply that out, and we get x squared plus 4x minus 5. And because it is opening down, that means this needs to be a negative. So our equation is y equals negative x squared plus 4x minus 5. And so I just realized I got ahead of myself just a little bit here. We do need it to open down, but the way it's written right now, x squared plus 4x minus 5 would open up. But we need to make sure that negative gets distributed to all of the factors, to all of the terms, sorry. So y is equal to negative x squared minus 4x plus 5. And I apologize about that. So once again, that negative needs to go to all of the terms. Question 93. Find the slope and y-intercept of the line 6y minus 3x is equal to 24. This problem is asking for the slope and the y-intercept, so I think this would probably be easier just to write this in y equals mx plus b form or slope-intercept form. And so to do that, we want to isolate the y value. So we'll add x to both sides. 6y equals 3x plus 24. And then we can divide each term by 6, and we get the equation y equals 1/2 x plus 4. So that means that the y-intercept is at 0, 4, and the slope would be 1/2. Question 94, examine the graph of y equals 2x squared plus 2x minus 1 at the right. Estimate the zeros from the graph. So if we're just looking at the graph itself and not using our graphing calculators, it appears that it crosses the x-axis a little after the -1, maybe not quite in the middle. But it does appear that x is somewhere around the -1 point, maybe not quite 5 yet, -1.4 maybe. And then on the other one, here's 1 right here, and once again it's a little bit closer to 0 than it is the 1 value, so maybe 0.4, maybe 0.3 on that one, somewhere in there though. So x is approximately 0.3. And then on B, what happens if you try to use the zero product property to find the roots of 2x squared plus 2x minus 1 equals 0? Well, let's find out. 2x squared plus 2x minus 1 is equal to 0. So we got to figure out whether we can factor this. So we have a 2x squared and a minus 1. I'm going to use our diamond. The product has to be negative 2x squared, and it has to add up to 2x. So really the only thing we use is 2x and 2x, or 2x and 1. One of those would be a negative, and then that's not going to give us the sum, which is 2x. So this is not factorable. Okay, and I think we've answered the question. What happens if you try to use the zero product property? Well, because it's not factorable, we don't have any factors to set equal to 0. And I think that finishes up question 94. Question 95. Solve the equations below for x and check your solutions. So we're looking at some quadratic equations, and we're solving for x. Once again, remember that's the when y is 0, what is x? So those are our x-intercepts, our roots, and zeros. So looking at part A here, we want to be able to use the zero product property, so we need to factor. And you can use your generic rectangle to be able to factor. That would leave us with x squared. So x times x is x squared. We'd have a plus 10 and a minus 4. And once again, you can use your generic rectangle to be able to factor that. Now we're going to use the zero product property. Set our factors equal to 0. And then we'll solve when we get two solutions. X equals negative 10 and x equals 4. And it does want us to check our solution. So to do that, we would plug those back in. And so we can either write our solution in a solution set like this, or we can just leave it this way. Either way is fine. And so to check this, we would plug negative 10 back into the equation for all values of x, and then see if it works out. So we have 100 minus 60 minus 40, and that would satisfy that. So that one works, and then we also plug in 4 because we want to make sure both of them work. 4 squared plus 6 times 4 minus 40 is equal to 0. So 16 plus 24 minus 40, and that would be 40 minus 40. So 0 is equal to 0. So the check works as well. So on part B, we're going to do the same thing. We have 2x squared plus 13x minus 24 equals 0. So once again, we do need to factor this. Let's go ahead on this one and do the generic rectangle so you can see that as well as a review. This would be 2x squared and negative 24. So going back to Casey's thing that she found about the diagonals, we would know that this would be negative 48x squared, and it has to add up to a total of 13x tiles. So what are factors of 48, negative 48, that are going to add to give you 13? And so as you look at your factors, you have 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Because of the negative 48, one of these numbers needs to be negative. We just got to figure out which one. So if one of them is going to be negative, we're looking at the difference. So 16 and 3, but we need one of them to be negative, and then 3 should be negatives to get, when you add those up, you get 13x. So we have a 16x and a negative 3x that we complete our generic rectangle for. And now we have to figure out what the side lengths are. So we got a 2x and an x. That allows us to do 2x times 8 to get 16x, and then on the bottom here, x times negative 3 gives us negative 3x, and then you can check your last box. 8 times negative 3 is negative 24, so it does work out, which leaves us with 2x minus 3 and x plus 8. And now we can set our factors equal to 0 and solve. So 2x is equal to 3, x is equal to 3 halves, or 1.5, and then on this one subtract 8, x is equal to negative 8. So x is 1.5, or x is negative 8. Or once again, if you want to simplify that a little bit and write it in as a set, be x equals, once again using the curly bracket, negative 8 comma 1.5 or 3 halves. And once again, we want to check these, so go ahead and plug those numbers back in and see what you get. And so there are the two checks, once again showing that negative 8 and 1.5 are both solutions. Question 96. Calculate the expressions below. Then compare your answers from parts A and B to those in part A of problem 8-95 and part C and D to part B in problem 8-95. What do you notice? All right, well, let's go ahead and calculate the values for A and B, and then we'll compare. So on A, we have negative 6 plus the square root of 6 squared minus 4 times 1 times negative 40. And that whole thing is divided by 2 times 1. So you can simplify this individually. You can plug it all into your calculator at once. I'm going to simplify what's underneath the square root, and then we can plug the rest of it into the calculator. So 6 squared is 36. And then when you go to multiply these next three, you have that negative or that subtraction sign in front of the 4. Multiply all three of those together. And so if you multiply all three of them together, you're going to get positive 160. So that's plus 160, and then divided by 2 times 1, which is 2. So let's simplify one more time before we plug it in. Negative 6 plus, and then this would be 196 over 2. So let's go ahead and plug that in our calculator and see what we get. So we get negative 6 plus 14 divided by 2, which would be 8 divided by 2, and that is 4. So we get a value of 4. Let's do the same thing with B, and then we'll go back and compare. So B, when you first look at it, it looks exactly the same. The only difference is this one has a plus and this one has a minus. Everything else is the same. So we really can go to the end here and get negative 6 minus the square root of 196 divided by 2. And even simplify that to negative 6 minus 14 divided by 2. And so that's negative 20 divided by 2, or negative 10. So A was 4 and B was negative 10. Now let's go back and compare to what we just did on problem 85. And if you go back and look on 95 here, look at part A. You have a solution of x equals negative 10 and 4. And go back, and what did we get? We got 4 and negative 10. So the solutions, and in terms of what we're evaluating the expression, we're getting the same numbers there. And so what I challenge you to do is, if you're looking at A and B on this and it seems to be a mess of things, those numbers are coming from somewhere. So if you compare that back to the problem that we originally had, do you notice any numbers from this equation that are being used in these two expressions? Okay, and just kind of leave it at that, but just you can kind of compare and see if you notice anything that is similar between those two. All right, let's go ahead and move on to C and D. So on C, it seems like we have the same type of problem where it's exactly the same except one is subtracting and one is adding. So the first one, we'll go ahead and do negative 13 minus the square root. 13 squared is 169, and then once again you have right here minus 4 times 2 times negative 24. So two negatives are going to make a positive. So if you multiply that up, what do we get? We get a positive 192. And then that is being divided by 2 times 2 this time, so that's 4. And this will equal, let's keep simplifying. What's 169 plus 192 is 361 divided by 4. And if you take the square root of 361 in your calculator, you'll get negative 3. Well, you won't get negative 3 for that, but you'll have negative 3 minus, and the square root of 361 is 19 over 4. So we can continue to simplify. This would be negative 22 divided by 4, which is equal to, I just noticed I lost a 1. It was minus 13, not 3, so negative 13 minus 19. Let's fix that. And that would be negative 32 divided by 4, which gives you negative 8. And then on the same thing for part D, but it is a plus sign. So the only thing we need to change is to go through and change it to a plus square root of 361. So I'm going to go right to that point. Negative 13 plus the square root of 361 divided by 4. So that's negative 13 plus 19 divided by 4, or 6 divided by 4, which is 1.5. So once again, comparing that back to question 95 on B, look at what your solutions were. Negative 8 and 1.5. So going back here, we get negative 8 and 1.5. So once again, if you're trying to make a comparison of those two, look at the original problem and the 2, the 13, and the negative 24, and see how that applies to where the numbers are going in this expression. Question 97. Use any method to solve the system of equations below. So we are back to solving a system of equation. We have 2x minus 3y equals 5. We might take the second equation here and multiply by 3, so I'm going to use elimination. And I'll add those up, and I get 14x is equal to 14 divided by 14, and x is 1. Plug that back into one of the two equations. I'm going to go ahead and go to the first one. So I have 2 minus 3y equals 5. Subtract the 2 to get 3, divide by negative 3 to get negative 1. So since we are solving a system of equation, we want to write that as an ordered pair, 1 comma negative 1. On to B, we have an m and an n. So m is equal to negative 3 plus 2n. And so I would say this would be substitution. And I can plug that in for the m in the second equation. So 4 times negative 3 plus 2n plus 6n is equal to negative 5. That's negative 12 plus 8n plus 6n is equal to negative 5. And I put an x there for some reason. I just realized. So let's fix that. That's negative 12 plus 8n, not 8x. I can add 12 to the other side, and also combine my 8n and 6n to be 14n. Divide by 7, or equal 7 divided by 14. N is equal to 1/2. Take that, plug it back into m equals negative 3 plus 2 times 1/2. And it looks like we'll get negative 3 plus 1, where m is equal to negative 2. So we would write these in alphabetical order since we're not using x and y, and that would be negative 2 comma 1/2. And remember, you can always check these. Anytime you're solving an equation, you can always check them by plugging them back in and see that they work.